Okay, good day, and today we'll proceed in chapter 12 about ideal gas mixture and psychrometric applications. So, the objective of this chapter is to study mixtures where the overall mixture and its component can be modeled as ideal gas. Okay, so from the previous chapter, we are dealing only with single substances, no? Or pure substances. But for this chapter, we'll model mixtures. So it is composed of one component or one or more, two or more components or substances. So how do we get the internal energy, the enthalpy, entropy, as well as how to model those processes. So let us first recall some common terms used in defining mixtures. So first of which is the number of moles, or denoted as N sub I. So the number of moles is just equal to the mass of the mixture divided by the molecular weight. So the symbol for molecular weight is capital M. Okay, so the total mass of the mixture is just the summation of the masses of individual components. If we divide this equation by the total mass, we'll get the mass fraction. So mass fraction is M sub F, mf sub I is just equal to the mass of the component divided by the total mass. So if the mixture is described by its mass fraction, so it is called the gravimetric analysis. Now, if you sum up all the mass fraction, it should equal to 1. Okay? In the same way, the total number of moles in a mixture is just the summation of the individual number of moles of its components. So if we divide this equation by the total number of moles, we'll get the what we call the mole fraction. So the mole fraction is just the number of moles of a certain component divided by the total number of moles. So if the mixture is described by mole fractions, it is called the molar analysis. Okay. Again, so summation of the mole fractions should equal to 1. So the molecular weight M is just equal to the mass of the mixture divided by the number of moles. So ang unit ano niya is kilogram per kilomole. Okay? So example of mixture is the air. So air is composed of nitrogen, oxygen, argon, carbon dioxide, neon, helium, methane, and others. Now this is described in mole fraction. So it is nitrogen is 78%, no? Composition sa air is nitrogen. So by mole fractions. Okay? So if you want to get the molecular weight of a certain mixture, you can use this equation, no? You sum up all the masses and then divide by the number of moles. Okay, or you can ang mass nimo is just equal mo na siya sa N1M times the molecular weight. So kaning N divided by the capital, this is mole fraction. So the total molecular weight of a certain mixture is just the summation of the mole fraction times the molecular weight of the components. So kung gusto na ay mixture diha, then wala ka kabalo pila ang molecular weight ana, can use this equation. So say for example, for air, pila ang molecular weight sa air? You multiply this one 0.78 times pila ang molecular weight sa nitrogen. So nitrogen is 28. So mo ni siya. Therefore, ang molecular weight sa air is 28.97 kg per kilomole. Now, if you want to convert mole fraction to mass fraction, so just solve this problem, no? Molar analysis of gaseous products of combustion. So molar analysis, so kaning 0.08, this is mole fraction, no? Mole fraction, and then you need to convert this to mass fraction. So first is determine the molecular weight of the mixture. O sample kani. Dili given ang chemical formula sa mixture or sa hydrocarbon na fuel. But given ang iyang composition in terms of molar analysis, you can still get the molecular weight. Kung saan nila ito by kani mole fraction times the molecular weight of CO2 plus 0.11 times molecular weight of H2O. So mo ni. Therefore, you can get the molecular weight which is 28.46 kg per kilomole. Okay, then letter B, determine the composition in terms of mass fraction. So you need to convert mole fraction to mass fraction. So how do you, so ano mo na pagbuhat? Okay, you can use this table. First is assume 1 kilomole na mixture, no? 1 kilomole na mixture. So you assume a 1 kilomole na mixture, and then so makuha na nimo ang number of moles per component. So example kay kuan man ni 0.08 man ang carbon dioxide. So 0.08 pod times 1 is 0.08. So therefore 0.08 ang total ani nila is 1, no? So, total. And then you multiply that by the molecular weight. So makuha nimo ang mass. Pila ang mass sa CO2? 3.52 kilogram. No? And then and so on. And then you sum up the, kaya ang kinahanglan mo sa mass fraction is kani massa component ng CO2 and then the total mass which is 28.46. I-divide din mo ni 3.52 divided by 28.46. You'll get this one, 12.37. Okay? Okay, so muna din ang mass fraction. Okay? So in the same way, converting mass fraction to mole fraction, just you need also to get the total number of moles and the number of moles, and then divide that one, you can get the mole fraction. Okay, let's proceed with the relating pressure, volume, temperature for ideal gas mixtures. So how do we describe a mixture, no? Na ay duha ka model that are used to describe a mixture. So ang isa ka model na is the Dalton model and the other one is the Amagat model. Okay, so this is the equation for ideal gas. Pressure is just equal to number of moles, R bar, T over V. No? So, ang R bar is muna ang universal gas constant. Okay? So, what is the Dalton model? We will use this diagram in order to illustrate these two models. First, the Dalton model assumes that its mixture component behaves as ideal gas. No, so kung naay pila ni diri. Sample nato no naay duha ka component, gas 1 and gas 2. Using the Dalton model, assume niya nga every component behaves as ideal gas. So ma-apply na to ang ideal gas equation as if it were alone at temperature and volume of the mixture. So importante kay ni nga phrase no, as if it were alone. So pasabot ani niya using the Dalton model, ang imong mixture is composed of many components. So ang isa ka component gi-assume niya nga gi-occupy niya ang tibuok volume kani tibuok volume assume na niya. So meaning the volume of component 1 is just equal to the total volume is equal to the volume of the another component. No? Okay, so let me illustrate that. Okay, so if this is the volume, no? Total volume ani is V. Okay. If the total volume of this cylinder is V, so kung naa kay duha ka component component A, sample this is component A, and then and this is component A, and this is component B. Okay, so okay. So ang volume for Dalton model, okay, this is for Dalton model. For Dalton model, i-assume niya nga ang volume sa A is just equal to volume sa B is just equal to the total volume. I know. Again, volume of A is just equal to volume of B is just equal to the total volume. Okay? So muna yung assumption sa Dalton model. Okay, so meaning kasi pasabot ani niya. Kani ko nga mixture A gi-occupy niya ang tibuok volume. Kani nga mixture B gi-occupy niya ang tibuok volume. And then the same sila og temperature. But ang pressure nila is lahi-lahi, no? Ang total pressure is the sum of pressure of B plus partial pressure of B, no? So, mo ni ang assumption sa Dalton model. So, balik to dere. For the Dalton model, the total pressure is the summation of the pressure of the component. So, mo siya. So, if we divide the thus the partial pressure of component I can be evaluated in terms of its mole fraction y sub I. So, ang pasabot ani, ang kung i-divide mo ang pressure sa component 1 divided by the total pressure, this is just equal to the mole fraction of that component. No? So, kung naa kay mole fraction, makuha nimo ang partial pressure sa imo ang mixture. Mo lang multiply sa total pressure. May pasabot ani. Okay, let's proceed with the Amagat model. For the Amagat model, okay, let's change this one. Amagat. For the Amagat model, ang assumption niya is the total pressure is just equal to the partial pressure of A just equal to partial pressure of B. So, unsay pasabot ani niya? Ang Amagat model states that wala. Amagat model states that ang mixture ay mo ang component A is the same og pressure sa sa total pressure nimo diri, no? Ang difference nila is mura sila bali, no? Ang using Amagat model, ang volume sa total volume is the summation of volume of A and B, no? So, mao ni siya assumption sa Amagat model. Okay, so for the Amagat model, again, summation of the total volume is just equal to the summation of the individual components, no? Volume of individual components. Okay? And then, ang volume, divide nimo ang volume sa for component 1 divided by the total volume is equal to the mole fraction. So, makuha nimo ang volume, pila ang volume ani nga component by multiplying it by the mole fraction. Okay, so we will use these models later on. Okay, evaluating the internal energy, enthalpy, entropy, and specific heat. Okay, so how do we evaluate mo ning ato ang meet sa atong discussion, no? Evaluating the internal energy and enthalpy and entropy for a mixture. So unsa ato pag-evaluate? So let's consider a closed system consisting of ideal gas mixture. So extensive property of mixture, internal UH entropy can be found by adding the contribution of its component at the condition at which the component exists in the mixture. So, pasabot niya is the total internal energy of the mixture is just equal to the individual internal energy of the component. So, it's equal to summation of internal energy as well as the enthalpy. Okay? Now, in terms of molar bases, kaning imong capital U, this is just equal to the number of moles times U bar. Kaya ang kaning pasabot aning U bar, specific internal energy, pero di siya per mass, per mole basis na siya. Per mole of mixture. So, kaning equation og kani, the same ra ni sila. As well as kani o kani. Okay? And then, kung i-divide nato ni by the total number of moles, this will result to this equation. Internal energy is just equal to the mass mole fraction times U sub I, or the individual internal energy. Okay, for the specific heat, CV and CP, again, almost the same ra niyo. You multiply the mole fraction by the individual specific heat. And the specific heat ratio is just CP over CB. Kani. Divide na nimong duha. Okay, how do we evaluate entropy? So for entropy, again, the same. You add the entropy of every component. That's one. And it will result to this equation. Okay. So per mole basis to siya, per mole basis. Again, pwede po nimo ni siya pwede po per mass basis. Instead nga kaning bar imong gamiton dire, katong specific internal energy imong gamiton na per mass basis. Okay. By using the molecular weight of the mixture of the component, data can be converted from a mass. Okay, so kung gusto nimo i-convert from mass basis to molar basis, you just use or multiply the molecular weight. Yan. Okay. Okay, so let's analyze systems involving mixtures. Okay, so how do we evaluate the change of internal energy and change of enthalpy and entropy? So, unsaon man na siya? Based from this one, no, this is ang imong internal energy and enthalpy is function only of temperature, no? But your entropy is a function of temperature and pressure. So for the change in internal energy, again, ang capital U is just equal to the mole, number of mole times the specific internal energy per mole of mixture. So kaning equation, same ra need to taas. But you need to evaluate it at temperature T2. Kani pangitaon nimo ning internal energy ani kay naman is stable man non-stable. Okay? Again, delta U, if you divide this one by capital N, is just equal to delta U is just mole fraction times kani. For entropy, again, Ni Si, or multiply the number of moles times the entropy per mole. And then you need to pagitaon nimo ni base man sa temperature and pressure. Okay, so medyo how do we evaluate this one? So dire you use the ideal gas table. So kani siya nga equation, this is just equivalent kaning expression, equivalent ra ni siya ani. S sub I degree T2 minus kani minus T1 minus R bar. So this is the universal gas constant times ln Pi2 over Pi1. Since the mixture remains constant, the partial pressures in this expression is the same as the mixture pressure. No, so gayon yung ang component daw ang partial pressure sa component 2 is just equal to the total pressure at state 2. So this is using the Amagat model, no? Kani. So kani nga expression, kani, or rather, kani nga term, kani, oh. This is just equal to, mahimo na dahil sa ninani, minus R bar ln P2 over P1. Okay? Again, unsay assumption ani? Mixture remains constant. Okay, assuming constant specific heat. So, kung constant imong specific heat, mahimo na ning kaning U. This is just CV T2. Okay? So, you can also use this one, no, if constant ang specific heat. Okay, so let's have this example. Compressing of an ideal gas mixture. So, a mixture of 0.3 kilogram carbon dioxide. So, this is per mass basis, no? Gravimetric analysis. And 0.2 kilogram of nitrogen is compressed from 1 bar and temperature of 300 Kelvin to pressure of 3 bars in a polytropic process, for which the exponent n is 1.25. Determine the final temperature in Kelvin, the work in kilojoule, the heat transfer in kilojoule, the change in entropy of the mixture in kilojoule per Kelvin. Okay, so sa imong buhatan na nino, first is you determine the final temperature. So, unsa na nimo pagbuhat? You use the polytropic process. Diba ang polytropic process is PV to the N. Okay, so let's solve this example. You have a mixture of 0.3 kilogram CO2, 0.2 kilogram of nitrogen is compressed from okay, so this mixture is compressed from pressure of 1 bar. Actually, this is 1 bar. Point 1, point 2. The temperature T1 is 300 Kelvin. P1 is 1 bar. And then state 2, this is 3 bars. Okay, P2 is 3 bar. Okay. So we are asked to find the polytropic process. The exponent is 1.25. 1.25. Okay, determine the final temperature. The work in kilojoules. The heat transfer in kilojoules. And entropy, change in entropy. Kilojoule per kilogram. Kilojoule per Kelvin. Okay. Okay, so we are asked to find the final temperature. So, aha to magsugod ano no? So, we'll start with the polytropic process. PB to the 1 to the n is equal to constant, right? So, you have P1, B1, P1, B1, B1 n minus 1, B2, 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 minus 1. And again, this term is just equal to R T1, right? RT1. So, mabilin ani, mahimo na nanin. T1, V1, minus 1, T2, V2, and minus 1. So, pangitaw na to ang T2. T2 is T1 times B1 over B2 and minus 1. And then, the volume, di man given, but you are given the pressure. So, again, we'll use unsay value ani. P1, B1 to the N, P2, V2 to the N. So, V1 over V2 is just P2 over P1, 1 over N. Tama? May mananing P1, P2 over P1, N minus 1 over N. Okay? Okay, if we plug in the values, 300, your temperature must be in Kelvin. 3 over 1 raised to 0.25 over 1.25. The answer would be T2 will be 374 Kelvin. Okay, ano siya? Okay. Erase this one. Letter B. So, ang answer ani is 374 Kelvin. Now, the work. Okay. So how do we find the work? Okay, so let's find the work done. Work for a polytropic process. Okay, derive na to, no? For a polytropic process. Okay, so your pressure is just, okay, we need to find an equation that would relate to the volume sa makuha na dire. No? Again, dili nato ni siya ma-evaluate kung dili ni siya in terms of volume or constant ni siya. Dawara na ka scenario. So, this is just C over V to the N. V to the N na nato gagawin. dV. This is just constant pagawas, negative N. So, V1 minus N over 1 minus N. 1 to 2. No. 1 to 2. V1, V2. Okay? V1, V2. So, this will become C. Okay. C V2 1 minus N 1 minus N minus V1 minus N. Okay. No. Ito na lang yung distribute CV2 minus CV1. Okay. Or this is just equal ang C ni mo, recall C is just P2 V2 to the N, or C is just P1 V1 to the n. So mahimo na lang dining. Yeah, 1 minus n man eh. Mahimo na lang dining P2 V2 minus P1 V1 over 1 minus n. Tama? Okay. Ano siya? Again, wala man tayo volume. Ito na ang kuanon. Using ideal gas equation, this is just equal to kay ang, diba? P is just, sa galit ng ideal gas, P is M R bar V T here PB MRT. Okay, PB MRT. Okay, so muna siya. Ito na i-substitute diri. Therefore, work is just, mahimo na lang siyang M R bar over M T2 minus T1 1 minus N. Okay? Tama? Okay. Isa na ako na eh. This one. Okay. Kani nga term total mass na this is just 0.3 plus 0.2. So this is 0.5 kilogram total mass. And then, what is the molecular weight? Molecular weight. Takabalo no kayo. Takabalo sa chemical formula ani. No, kung mo ni mixture ni mo na ay CO2 na ay N2. Takabalo unsay tawag ani nga mixture. So makuha na to ang molecular weight by saan man. M is just recall. M is just na. So kani total mass na total number of moles wala pa or given na pero makuha na to, right? Kani ang total number of moles, this is just N CO2 plus N2. Okay? And then what is number of moles of CO2? This is just mass of CO2 times the molecular weight of CO2. So this is 0.3 kilogram, and then ang molecular weight sa CO2 is 40 bali ang equation. And CO2 is over molecular weight CO2. So this is 0.3 kilogram over molecular weight is 44 kilogram per kilomole. So ang answer ani would be 0.0068 kilomoles. And CO2. And nitrogen. So pila ang masa nitrogen? 0.2. And then ang iyang molecular weight is 28. So ang answer would be 0.0071 kilomole. Okay, the total moles. I-add na nato ning duha. And is just 0.0068 plus 0.0071. Which the answer is 0.0139. Okay. Makuha na dahil nato ning molecular weight, which is, what is this one? Molecular weight for the mixture is 0.5 over 0.0139. Answer would be 35.97. Unit is kilogram per kilomole. Okay. So, ito na i-plug in dire. M 0.5. Ang R bar nimo is 8.314 kilojoule per kilomole Kelvin times T2. Ilan T2? 374 minus 300, 74 Kelvin na lang. Over molecular weight, 35. Dapat ang unit aning ko is kilojoule, no? 35.97 kilogram per kilomole times 1 minus n, so negative 0.25. Okay? Okay. So, tanawan na itong unit. Kilogram, cancel. Kilomole, cancel. Kelvin, cancel. Ang bilhin is kilojoule. So, ang answer ani, work is negative 34.21 kilojoule. Okay, this is the work. Negative because compression man eh. So, tama. Negative 34.21. Okay, again, this is 1. The heat transfer. Now, this is a closed system. So, we will apply the first law. Delta U, okay, negligible man ang potential of kinetic is just Q minus work. So, Q is just delta U. Delta U is just U2 minus U1 minus plus work. Okay? This is just equal to, now kaning internal energy, again, this is just equal to NCO2 times internal energy CO2 evaluate at T2. Okay? Minus U CO2 T1. Tama, kay duha man ni ka component plus N2 U bar N2 minus U bar N2 T1. Okay. So again, gani nga mga value na sa table, no? Table. So based sa table, kung sa may pila ang ganito number of moles nimo, number of moles aning CO2 is 0.0068. Kaning U internal energy of CO2 at temperature 374, imo pa ning i-interpolate sa table. Okay? Okay, table 823 for Shapiro. Based to imong interpolate, you will get a value of 9198. And then, ang kaning for temperature 16939 na siya. Plus NN2 0.0071 times 770 minus 6229. Okay? So, ang answer na yan mo, delta U. Oh, by the way, this is delta U kaniha. Delta U is equal to 26.3 kilojoule. So, kung kuha na to ang Q is just delta U plus work. So, 26.3 minus kay negative man to 34.21. Pila ang Q? Negative 7.91 kilojoule. No? So, mauna siya. Negative. Kasi pasabot to negative. Going out of the system. Okay. That's it. So, ang kuan ni is kanira. You get the number of moles times internal energy per mole. Lastly is the entropy. Ang entropy nimo, again, the equation sa mong entropy, delta S is just N CO2 tapos delta S bar CO2 plus N N2. Okay. So, this is just equal to 0.0068. So, ang equation ani is okay, so this is ang equivalent ani is kani. Kani nga expression again, naman sa book. So, what do you do is may tao nimo ni sa table kani sila. Table 823 068. So, based sa table kani, nailalim na temperature ko T2 o T1. So, imura ning interpolate. So, medyo taas na gid ni siya kay duha naman ni ka component. Minus 213.915. Tanawon po nimo ang consistency sa unit ani. Minus 8.314 ln of ln3. Right? Plus 0.0071 kani sa table gapon 198.105 minus 191.682 minus 8.314 ln3. So the answer would be delta S is just equal to negative 0.0231 kilojoule per Kelvin. Okay, so that's it. So practice solving. There are many examples in the book.